Hello everyone, and welcome back to the last topic for section 8.1, which is equations of quadratic form. So the thing that we want to remember when dealing with quadratic equations is that the general form is always written as au squared plus bu plus c equal to 0, okay? That's the general form that we want to remember, okay? And the reason for that is when we're dealing with larger forms of an equation that's similar to the quadratic equation, we can always use some type of substitution to reduce it down into this general form and then solve for it. So, for instance, if I had x to the fourth minus 13x squared plus 40 equaling 0, well, how would I go about solving this? So what I can do is I can recognize that x to the fourth is really x squared squared, okay? And so that's still being subtracted by x squared plus 40 equaling 0. And the reason why I've written both of these in parentheses is because now what I'm going to do is that I'm going to do a substitution. So what I'm going to say is that I'm going to let u equal x squared. And what that'll do is that will allow me to rewrite this equation that's in the power of 4 back down into the quadratic form. So I'll have u squared minus 13u plus 40 equaling 0. And now it's a lot easier to solve for, because now I can just factor this very easily. So I have u right there, okay? And my c term is positive, but my b term is negative, and because of that, I know that both terms will be negative, okay? And the factors for 40 that will add up to negative 13 are negative 8 and negative 5. So then my solutions are u minus 5 equals 0 and u minus 8 equals 0, which gives us rather u equal to 5 and u equal to 8. But I have to remember that u is really equal to x squared, okay? So now I have to substitute my x back in, so I'll have x squared, which is equal to 5, and x squared, which is equal to 8, okay? So then if I take the square root of both sides for x squared equals 8, I'll get x is equal to plus or minus the square root of 8, which can be simplified into plus or minus 2 times the square root of 2, okay? And likewise, for x squared equals 5, I have to take the square root of both sides, and I'll get x is equal to plus or minus the square root of 5. And as you can see, we really have 4 solutions, which is what you would expect for an equation where we have x raised to the 4th power, right? Because we have positive square root 5, and then the negative square root of 5, and then plus or minus the square root of 2 times the square root of 2. Okay, and then to look at another example, I think I'll have enough room here, so what I'll do is that I'll just box this off right here. If we have x raised to the 2/5 power minus 2 raised to the 1/5 power minus 48 equals 0, how do we go about solving this? Well, we can rewrite x raised to the 2/5 power as x raised to the 1/5 power squared minus 2, and then in parentheses here, raised to the 1/5 power minus 48 equals 0. So as you can see here, what's in parentheses will be my u substitution. So I'll have u equal to x raised to the 1/5 power. And so then I can say I'll just stay in green. I can say that now I have u squared minus 2u minus 48, which is equal to 0. And now I can solve this by factoring as I normally would. So I have u and u right here, which is equal to 0. And now what I want to do is that I want to think of two numbers that when multiplied together give me 48, but when added give me negative 2. And those two numbers would be negative 8 and positive 6. So then to solve this, I set each of these guys equal to 0. So I have u plus 6 equal to 0, and I have u minus 8 equal to 0. And so u is equal to negative 6, and u is equal to positive 8. And then to solve for this, right, u is really equal to the square root of u is really equal to x raised to the 1/5 power, or I guess you could say the 5th root of x, right? So we substitute that back in for both of these. And since we're taking the 5th root of x, we have to raise both sides by the 5th power. And I kind of regret doing 1 to the 5th, but negative 6 raised to the 5th power will give us, so I'll write this down here. So x is equal to negative 6 raised to the 5th power, and that is equal to negative 7,776. And our second solution for x is, so if we have this, raise both sides to the 5th power, and so x is equal to 8 raised to the 5th power, and that is 32,768. Okay. So yeah, obviously as you're if you're dealing with powers like these, your answers are going to be incredibly large. But you know, it all worked out in the end. So finally, what we want to look at is an application for solving once we solved our quadratic equation, what the answers can give us. So if I have a softball, draw a ball here, okay, and its surface area is given by S is equal to 4 pi r squared, and I'm also given the surface area, which is equal to 64 divided by pi. What I want to do here is that I want to find out what the denominator, I mean not the denominator, but the diameter of my softball is. Okay, man, diameter and denominator. Can't believe I got those two confused. But yeah, so I want to solve for the diameter of my softball. Okay, so what I can do is that I can substitute in my value for the surface area. So I'll have 64 divided by pi, which is equal to 4 pi r squared, and then I can divide both sides by 4 pi, and that will give me r squared is equal to 16 divided by pi squared. Okay, and now what I want to do is that to obtain solutions for r, I just take the square root of both sides, and I'll get r is equal to plus or minus the square root of 16 divided by pi squared. And it doesn't make sense for us to have a negative radius, so we can just reject the negative root. We can just reject the negative solution that we get for r. So our only r value is then the square root of 16 divided by pi squared, which can be reduced to 4 divided by pi. Okay, and the thing that we want to be aware of rather is that the diameter is is equal to 2 times the radius, okay? So since we solve for r, all we have to do is just substitute that value in, so we'll have d is equal to 2 times 4 pi. And so our diameter is 8 divided by pi. And I didn't bother with units, but let's just say that we were solving for the diameter in inches. So the radius is 4 divided by pi, and the diameter is 2 times that, which is 8 divided by pi, and that's in inches. Okay, that concludes this topic, and we also finish up with the first section in Chapter 8. So the next section will be 8.2, and that's completing the square. It's just another method on solving quadratic equations. Alright, see you next time.